Algebra 2. This is the video for the Pythagorean Theorem worksheet. So you do have some written materials already in your packet, and I'm just going to basically go through those. So if you're able to read and understand the printed notes, you really don't need this video, but if this video is helpful, then watch it. So in the notes, it's describing to you some things about right triangles. Right triangles have a right angle in them. When we have a right triangle, this longest side, the diagonal one that's across from the right angle, is called the hypotenuse. And then the other two sides are called the legs. They both have the same name because they kind of do the same thing. There's a relationship from the world of geometry that you might remember from PSAT reviews, or if you had geometry already from that class, or just, I think there's other times this might have been brushed upon in different subjects. The relationship is that if we call this A for short, and call this B for short, and call that C for short, A squared plus B squared equals C squared. In other words, if you take one leg times itself plus the other leg times itself, it would equal the hypotenuse times itself. So we're going to use this idea on the homework paper sometimes to find the hypotenuse. If you're trying to find the hypotenuse, we have a three-step plan. If we knew what these were, which we will, you'll have to square them both, add them up, and that would give you C squared. We don't want C squared, we want to undo that squaring, so step 3 will be to do a square root. So we'll be looking in our minds or on a paper to this familiar friend where we've seen this a lot lately. We've done a lot of root stuff lately, and that's why I tucked this in here coming off of the root chapter, because we've been doing this, so this is sort of fresh on our mind. So again, three-step plan. Square them, add them, root them. So if I give you a 3 and you square it, 3 times 3 is 9. Give you 4, you square it, 4 times 4 is 16. We always add, square them, add them, 25. Then we try to root 25. The square root of 25 is 5. Sometimes those answers turn out to be whole numbers. More on that in a minute. This one, same plan, but the root will go differently. We square 2 is 4. We square 4 is 16. We add them is 20. And if you try to do the square root of 20, it's not on our list. However, 4 is a helpful number for that. 4 can go into 20 5 times. The square root of 4 is good old-fashioned 2. And then the 5 just hangs out underneath the root. We've been doing that the last month or so pretty steadily. Same problem, different thing. Again, square this number is 25. Square this number is 36. We add those up. That's 61. If you try to square root the 61, it's not on the list like 25 was. And none of these numbers can help you the way the 4 just did. None of these numbers go into 61. So we're just going to do the square root of 61. That's it. Plan B is if I give you the hypotenuse, we have a different scheme here. The hypotenuse, again, is the longest one. So if I give you that longest one, we have to reverse the process. We're still going to square. 10 becomes 100. 8 becomes 64. But we're going to undo this. So instead of adding, we're going to be subtract. So we subtract, we get 36. We think about the square root of 36 using that same list that's way over on the left, but I'm not going to walk over there and make the camera person here as he's zooming back and forth. But the square root of 36 is 6. Same scheme here, square, subtract, and root. Squaring gets 25, subtracting gets 4, squaring gets 4. Okay, so we square, we got 25, we've got 4. Subtracting gets us 21. If you try to root 21, there's no way to do that. That just is as good as it's going to be. Last one of those, and then I've got a tricky tidbit. So this one we square is 36. We square 2 is 4. We subtract is 32. If you try to root 32, there's not an even way to do the root of 32. But 16 goes into that twice. So 16 can help us. The square root of 16 is 4. And then we've got a square root of 2 hanging out there. There's one bit of stuff not on the notes you have, that is on the worksheet. It talks about Pythagorean triplets. This very first problem I did, I found you what's called a Pythagorean triplet. That means I stuck with whole numbers, and there's not a lot of ways to do that. You notice most of these answers came up all rooty. For this to stick with whole numbers, there's limited ways to do that. And one of these triplets of numbers that will work is 3, 4, 5. So I have a tricky way to do some of these problems. If you like tricky ways, here's some tricky ways. So if we understood that 3, 4, 5 is a grouping of numbers that have to go together, this is really the 3, 4, 5 triplet, but in disguise. I took the 3, 4, 5 triplet, and I just multiplied all the numbers by 2. So if you knew 3, 4, 5 was a culmination, you might see that problem and go straight to the 6. The method we've been doing, the 3-step plan, square add root at the beginning, square subtract root when it went backward, is always true, always works, never going to be an issue. But sometimes if you see the triplets going, it saves you a little bit of bother. Like if I change this, wandering back to the left, if the original problem had 300 and 400, and you knew 3 and 4 are like things that will go together to make 5s. If 3s and 4s make 5s, 300s and 400s would have to make 500s. Or if I decided to do a 0.3 and a 0.4, all that's going to do is a 0.5. Like it's all in that 3, 4, 5 family. I could multiply everything by like 10. So if I threw you a 50 and a 30, 50 and 30's partner has to be 40, because 5s, 4s, 3s, they just go together. If you know 2 of them, you might be able to spot that sometimes. Another group that goes together is 5, 12, and 13. So if you saw a problem like, I just drew a blank one here. So if you had 0.5 and 1.2, we could just turn out 1.3. Or if you had 25 and 60. 25 and 60 is me taking these times 5. That's got to be 13 times 5. 8, 15, 17 is another group that goes together. That's another triplet on the list over there and that goes up here. So if I want to make a problem with a, I don't know, 16 and a 30, all I did is took this idea in my mind and I multiplied by 2. And we'd come up then with 34 if you multiply by 2. And then the last one, if we want to stick to numbers under 25, everything else would have to go over 25. The only other triplet with all the numbers under 25 is 7, 24, and 25. So if I went like 75, I'm probably multiplying everything by 3. You're not sure till I spot you another number, like a 21, and now all of a sudden, yeah, I'm committed to multiply by 3. If I did this times 3 and this times 3, you can safely then do that times 3. If that little trick helps you, that's speedier, but if you don't understand that, you don't have to. That's just sort of a shortcut. You can just follow the 3-step plan. So, if you have any questions out there in algebra land, email them to me. I'll try to get you in a future video.